My name is Mohamed Ismail. I also go by Mo. I'm an assistant professor of architecture at the University of Virginia School of Architecture. The Open Structures Lab is a multidisciplinary group of students and faculty, meaning me and the wonderful students I work with, both graduate and undergraduate, researching the ways that thoughtful structural design, accessible design tools, workflows that we can develop could potentially enable sustainable development worldwide. Research, to me, is not exciting unless there's a personal connection. And so I came to my research project through just a lifetime lived visiting family in different regions and seeing the sort of missed opportunities of our discipline where we weren't responding to the needs of people that needed it. This research really started when I was a graduate student at UVA doing my master's thesis. I had a background in architecture and structural engineering, and with family in Sudan and growing up in the Philippines, I'd always wanted to find ways to combine my interests in construction and design and housing and accessibility to problems that I cared about. I wanted to find out how the sort of economics, the socio-cultural dimensions of housing, the way people build and live and desire to live in the future could potentially be enabled through the work that me and my colleagues were doing. And so Open Structures just felt like a natural extension of that. I'm thrilled to have a pretty diverse set of students working with me. We have people who have studied English, computer science, people who are studying landscape architecture, civil engineering, material science, all contributing to this overall goal of just making the built environment more sustainable and healthy.
I'm Leo Wehner. I'm a second-year M.Arch Path 3 student at UVA School of Architecture. What drew me to this research is that it's unlike anything I've done before. I come from a literature background, so the opportunity to work on something like this, where it's extremely computational, you're working in Grasshopper, you're working in these optimization softwares, that is a unique experience for me. So a lot of this research, what's really interesting about it is that it's taking a beloved and sometimes controversial, but generally beloved system of construction, concrete construction, and making a system that can be adapted to local needs. Not just saying, this is how you build something, but saying, here's a set of tools that allows you to play with it, allows a diverse range of people to look at it and say, okay, I'm interested in this. It's making design more accessible.
To me, the research isn't done until we're able to put the work in the hands of people that need it. And so all of the questions of scalability are things like, how do we make these tools available to people? How do we prove that this is affordable? That complexity in structural design doesn't necessarily mean that you have to spend more money to build it. So an industry partner that we have recently been working with is our members of the Precast Concrete Institute. They have generously supported teaching in precast construction, but they've also given us feedback on the work that we're doing. One of our projects is really just how do we take the tools of low carbon structural design and start to add on a cost incentive? How do we actually justify that we can somewhat predict how expensive structures will be, because ultimately none of this matters if the bottom line isn't met. On the other side, we also have people in design practices and engineering firms who want to hear more about the work. And so more recently, we've been invited to present and talk about how some of the tools, even if they're still very much in beta, could be put in their hands of entrepreneuring engineers and architects that want to try new tools that just haven't been available to them in the past years, and also help us make those tools better and more precise and realistic, which is ultimately the goal for all of it.